Good morning, children. This is Mrs. Adi Joseph, your physics teacher. Welcome back to the online teaching for the session 2020-21. I hope all are keeping fine. Stay home, stay safe. Let us see the next chapter. That is magnetic effect of current. You have seen that there are three effects of current. That is heating effect, magnetic effect, and chemical effect. In the previous chapter, you have already learned about the heating effect of electric current. What is heating effect of electric current? When current flows through a conductor, it gets heated and it can be used for different purposes. For example, this heating effect of electric current is using an electric heater, toaster, geyser, etc. In this chapter, we will learn about the magnetic effect of electric current. First of all, we will see what is a magnet. Yes, a magnet is an object which attracts pieces of iron, steel, nickel, and cobalt. There are different types of magnets like bar magnet, horseshoe magnet, etc. A bar magnet is a long rectangular bar of uniform cross section which attracts pieces of iron, steel, nickel, etc. A magnet has two poles near to its ends. There is a north pole and a south pole as shown in the figure. The end of a freely suspended magnet which points towards the north direction is called the north pole, and the end which points towards the south direction is called the south pole. Now, what are the properties of a magnet? The first property is that a freely suspended magnet always shows the north-south direction. The north pole of the magnet is the side which points to Earth's geographic north when it is freely suspended. Second property is that like poles repel each other and unlike poles attract each other. That means a north pole repel a north pole and a south pole repel a south pole, but a north pole attracts a south pole and a south pole attracts a north pole. Do you know what are the uses of magnets? Magnets are used in radio, television, stereo speakers, in refrigerator doors, in children's toys, etc. What is magnetic effect of electric current? You know that a current carrying wire behaves like a magnet. That is, if you pass electric current through a conductor, it behaves like a magnet. We will prove this by performing an activity. Take a straight thick copper wire and place it between the points X and Y in an electric circuit. See the figure in your textbook, chapter 13, figure number 1. The wire XY is kept perpendicular to the plane of paper. Horizontally place a small compass near to this copper wire. Do you know what is a compass? A compass needle is a small bar magnet. The ends of the compass needle point approximately towards north-south direction. See the position of its needle. There is no deflection in the compass needle. Now pass the current through the circuit by inserting the key into the plug. Observe the change in the position of the compass needle. What you can see? And what does it mean? You can see deflection in the compass needle. It means that the electric current through the copper wire has produced a magnetic effect. Now, what is magnetic field? A magnet creates a magnetic field around it. The space surrounding a magnet in which magnetic force is exerted is called a magnetic field. I repeat, the space surrounding a magnet in which magnetic force is exerted is called a magnetic field. The magnetic field at a point is the direction of the resultant force acting on a hypothetical north pole placed at that point. Now let us see what is magnetic field lines. The path traced by a north pole free to move under the influence of a magnetic field is called a magnetic field line. In other words, the magnetic field lines are the lines drawn in a magnetic field along which a north magnetic pole would move. See the figure. These magnetic field lines, also known as magnetic lines of force. You can see that the magnetic field lines always begin from the north pole of the magnet and end on the south pole of the magnet. The direction of the magnetic field lines are shown using the arrows. Inside the magnet, however, the direction of magnetic field lines is from the south pole of the magnet to the north pole of the magnet. Remember, the direction of the magnetic field lines outside the magnet is from north pole to south pole, and inside the magnet it is from south pole to north pole. They are closed curves. Now, how to plot the magnetic field pattern due to a bar magnet by iron fillings? We'll do one activity. Fix a sheet of white paper on a drawing board. Place a bar magnet in the center of it as shown in the figure. Sprinkle some iron fillings uniformly around the bar magnet. Now tap the board gently. What do you observe? You can see that the iron fillings arrange themselves in a pattern as shown in the figure. Why this happens? The magnet exerts its influence in the region surrounding it. The iron fillings experience a force. So, the iron fillings show the shape of magnetic field produced by a bar magnet by aligning themselves with the magnetic field lines. What are the properties of the magnetic field lines? There are three properties. The first one is the magnetic field lines originate from the north pole of the magnet and end at its south pole. It always starts from the north pole and ends at its south pole outside the magnet. The magnetic field lines come closer to one another near the poles of the magnet, but they are widely separated at other places. That is the second property. See the figure. Here you can see that near the poles, these magnetic field lines are closer to each other, but they are widely separated at other places. That means the intensity of the magnetic field is more at the poles and less at other places. Third property is the magnetic field lines do not intersect one another. You can see these magnetic field lines are not intersecting each other. This is because the resultant force on a north pole at any point on a magnetic line of force can be only in one direction. If, however, two magnetic lines of force intersected each other, it would mean that the point of intersection, the compass needle, would point in two directions at the same time, which is not possible. We have seen that this magnetic field lines starts from the north pole to south pole. It cannot start from any other direction and ends at other direction. Only from the north direction to south direction. So they cannot intersect each other. Unidirectional. It is unidirectional. Okay. So this is the end of today's module. Go through the chapter. Read it nicely. If you have any doubt, the next day I will clear it. Till then, thank you. Bye bye and take care.